In this video, I'm going to explain the basics behind the unit circle and some definitions. These are like extra details that would help you understand what's happening with the functions. But if you want to boil it down into like the main basic information, you can watch the other videos related to the same topic. So the unit circle is a very common circle that we use in order to explain different concepts. So the unit circle is going to help us connect the circle properties, triangles, and trigonometric functions. So I'm going to call the sine, cosine, and tan as functions now. So they have a specific input and they give you a specific output. So what I'm going to do, this is a unit circle, meaning that the radius of the circle is 1. But I'm going to draw this unit circle on an x and y plane. So this is the Cartesian plane. And I could also define angles within. So these will make sense, the pi, 3 pi over 2, and so on. So this is my unit circle. It has a radius of 1. So if I move from the origin here, if I move from the origin of the circle until the edge of the circumference of the circle, the radius is 1. Now what I'm going to do is just pick a point P here, and I'm going to draw a straight line from P up until the origin. And this line has a radius of 1 because it's has a length of 1 because it goes from the origin to the circumference, and this is a circle with a radius 1. So what I'm going to do right now is draw a right angle triangle. So I'm going to just draw a triangle here, and now I have the triangle on the circle. So this P has coordinates x and y, and x comes from here and y comes from here. Well, another thing to note, which you should be aware of, is that the distance from here up until x, so the distance here is x itself. So the distance of this leg is x and the height is y. So it's exactly, the height is y, this is y, the horizontal distance is x. So I could write this as y and then this as x just to define the distances as well. Something else I'm going to do is define an angle. So I'm going to go anti-clockwise, which is how we will work with angles from now on. We're going to work anti-clockwise. So this is my angle theta. So now I'm going to use trigonometric ratios that we're used to. So I know that sine is sine theta, which is the opposite, so y over the hypotenuse, which is 1. And that's just equal to y. So sine theta is now actually equal to y. And then I have cos, which is cos theta equals to x over 1, which is just x. So now I have cos theta equals to x. And then tan is, sorry, should have written the ratios. So now tan is the opposite, which is y, over the adjacent, which is x. But actually y is just sine theta and x is just cos theta. And this is the first trigonometric identity you're introduced to. So this is the tan identity. Okay, so identity means that these two things are identical to each other. They're exactly equivalent. They're just different ways of writing them. So what we have established is an important relationship here between the coordinates and the plane. So right now, instead of writing x and y, I can replace it with cos theta and sine theta. So my x, as we have said, is cos theta. If you forget, then just think alphabetical order. C comes before S, so cos theta, theta, sine theta. And this works for any angle, whether you take it from here, whether I extend the angle here, whether I go like way beyond, it will always work. If I pick another point here, call it W, and I take the angle from, we always start from here and go anti-clockwise, and I take this angle, say alpha. And if I want to know the coordinates of this W, I can repeat the same thing. It's going to give me the values. But what's going to happen is that the signs are going to change. You're going to start to see different special properties about the signs, and something we call the associate acute angle. So that's all introduced in another video. What I do want to look at though is another identity. So now that we've established this relationship, there's something else we can do. So as soon as you see right angle triangles, they always tell you use trigonometric ratios, and obviously you want to use Pythagoras. So that's what we're going to do. So recall Pythagoras' theorem. You have the hypotenuse squared equals to the two legs squared. I'm going to call them a squared plus b squared. Our hypotenuse is 1 here, and one of our legs is, so we've established that this is sine theta and this is cos theta. Okay, so the length here is cos theta, the height here is sine theta. So the leg, which is x, is cos squared theta. Let me actually switch them. We tend to write sine first. Sine squared theta plus cos squared theta. So these are your x and your y as lengths. And this is a very important identity. This is called the Pythagorean identity. So the Pythagorean identity obviously comes from the Pythagoras Theorem, and it is a very important identity, and we use it to establish other identities as well. Again, it tells you 1 is exactly equivalent to this, and it comes from the unit circle, it comes from this property. And we tend to rewrite this and use this when we solve trigonometric equations. So you can use it such as, say, sine square theta equals to 1 minus cos square theta. And that's a different way of just rewriting this. And you might use this change of subject way to solve equations. So these are the two main identities you're usually introduced to, and they all come from the unit circle.